Okay. Two things before presenting the next speaker. I just want to remind you that with the badge, we invite you to come at Berăria Hash at 8 o'clock. There will be a party there, and the access is with the badge. Okay, so we expect you there. And the second, if you remind to give feedback in this maps or agenda, you have some small numbers near each topic, and you can check one number, meaning how much you like a presentation, if you like. Okay, thank you. Now, until the hardware is there, I will present the next speaker. The next speaker is Jorge Diaz. He's DevOps engineer at Xing, and he will talk about using container in IT. So, Jorge.
Hello? Yeah? Okay. Thank you. So, hi, my name is Jorge Diaz. I'm going to present to you my talk. It's called The Rise of Containers. And I have to turn it up, sorry. And so I'll do a small introduction. First of all, salute Bucharest. I'm very happy to be here. It's a great honor. Thanks to the organization for inviting me. Well, as he mentioned, I'm a DevOps engineer at Xing. If you are interested in things I have to say, you can check out my blog. It's mrdiaz.com. And you can follow me on Twitter on Diaz_Jorge. So I'm here today to talk to you about this technology that has me particularly excited, and it's about containers. But before we can talk about containers, it would be interesting to take a look back and see where we're coming from. And so in order to talk about containers, first we have to start talking about virtualization. And so we go to the beginning, and we're talking about hardware-level virtualization. So hardware-level virtualization started in the 60s, and with the first mainframes, right, they realized that when they were changing systems, and you have lots of code, mostly done in machine language or even in assembler, right? Well, people were not so keen on rewriting their whole software to fit a new architecture. And so they found this problem that it's easy to replace hardware, but software is more permanent. Seems kind of counterintuitive in hardware and software, right? But that was the first problem. And so they had to find a way to be able to run this old code on the new systems, right? And they also were finding that they needed better ways to separate the resources between multiple applications. So let's take a look at, let's say, our stack and how it works. Woo! Okay, so this is our basic stack when we're working with virtual machines. And so we have our physical server, and on top of that, we're running our host operating system. Now, on top of this is where we are going to tell our big fat lies, and we have this thing called an hypervisor. And an hypervisor is simply emulating the old architecture of our machines, right? And giving them access to the actual physical hardware. And then on top of that, we have our guest operative system. And then we will have our package dependencies. And on top of that, we will actually have our application code. So, well, what are the advantages of having hardware-level virtualization? So, well, you can run your old legacy stack unmodified. And you can mix and match operative systems. So you can have a Windows server on top of that be running Linux virtual machines. And for many use cases, that's the best solution. But it has also its disadvantages. Well, first of all, you have a big performance impact because, well, you're basically faking the whole machine, right? And it's because of the level at which we're doing the virtualization. And your virtual machine not only includes your application code and its dependencies, you're also including the whole guest operative system, which could be several gigabytes of information. So now we're going to talk about containers, and they're also a form of virtualization, but it's what is called OS level virtualization. So let's take a look at the stack and see how it differs from the other one. Well, sorry, before that, it all started at the beginning with chroot, then FreeBSD created the concept of FreeBSD jails. Then Solaris also expanded on that with Solaris zones. And then more recently, we had around 2005, so our projects like OpenVZ and Linux containers. So this is our stack, how it looks like. So we have our server, and then we have our host OS, right? And then on top of that, we have a very small virtualization layer, which is basically just making sure that the resources are isolated from each other between the different applications. Then we have our binaries and our application. And let's take a look side by side and see how they are different. And so we see that we replace our hypervisor, which is a very big layer. We replace it with something much thinner, like a Docker engine in this case. And then we got rid completely of the guest operative system. So what are the advantages of using OS level virtualization? So first, we got full speed, right? We're not faking anything here. We're not emulating any hardware. Your processes are running natively on the host operative system. You have better sharing of resources like rack and CPU, right? So your container can request 2 gigabytes of memory. And if it's not actually using them, then the operating system could be using this memory for its own internal processes, like caching, for instance, which doesn't happen with virtual machines, because it doesn't have the knowledge about what's happening inside the VM. It just assigns the full memory. In this case, it has the full knowledge of how much memory is actually used, and so you can share it better. And then your container includes only your application and your dependencies, so you don't need to provide the whole full guest OS. As everything, right, has some trade-offs and disadvantages. And the most important one is that it can only run one operative system. But on the good side, you can mix Linux distributions. So you could be running Fedora on top of Ubuntu, or Debian on top of Ubuntu in this case. So now I'm going to talk to you about Docker. And Docker, it's an open platform for distributed applications for developers and sysadmins. And I have to say, I'm really impressed. Docker was started barely 2 years ago, and this has been a technology that has gained so much widespread adoption. All the big players in the industry are really looking at Docker and how to support it. We had Amazon, Microsoft, all these huge companies are betting a lot on the power of Docker. Docker enables apps to be quickly assembled from components. So basically, we can be shipping small containers and then group them together in order to compose our systems. This is another advantage, and it's one of the, in my opinion, the most important ones, is you can run your same application code unchanged. And we're talking about the exact same code and same binaries, and you can run it on your laptop, you can run it on a data center, you can run it on the cloud, you can give it to a colleague on a USB stick, and you will get the same exact results, exactly, no difference. So of course, this has the win that it will eliminate friction between development, QA, and production environments. With Docker containers, there's no more, well, it runs on my machine. Well, no, if it runs everywhere. So, well, we have Docker, right? And it's got a it's got a lot of interest from the developer community. So why it's so popular? Well, first thing they do is, containers is not a new thing. There were others that were doing containers before, but they really focus on making it easy. Getting started and trying Docker is just a matter of downloading a package, installing it on your machine. 5 minutes later, you're already experimenting and trying and see how it feels. It lets you build any app in any language using any toolchain. And so now we're in days of service-oriented architectures. You don't have to be tied into the specific stack that is currently used. As a developer, you have full control into what gets installed into the container, which packages you depend, which programming language you want to use. It gives you a lot of control, and that's a big win. Forget installing, compiling libraries locally. When you download a Docker container, it's like basically getting a binary. You can be running the exact same versions of your external services. So if you're using MySQL 5.5 in production, you can be sure that you're using the exact same patch level for your development. No nasty surprises when you're actually deploying. Again, Dockerized apps are completely portable and can run anywhere. And you can just compose your systems from all these different parts. Docker also provides the Docker Hub, and it's basically like a marketplace where you can download containers for any kind of software that you can imagine. Most likely, there is a Docker container pre-built for it. And then this is like the final point that has really, really blown my mind. It's basically you have APT for applications. We're talking a whole different level here. We're not just installing binaries. We're installing complete systems. So what is the other side, right? So I'm working on DevOps, and so I've been in the development side. Now I'm more in the operations side, trying to bridge the gap. So if you're working in the operations departments, why is Docker interesting for you? Well, go back again to this. You have a standardized environments, right? So when you don't have these small differences between all the environments, then you can be sure that when things are running, if your tests are passing, then this thing is going to actually be running the same way without nasty surprises there. Flexibility to distribute where things run, right? We no longer are tied to a physical or a virtual machine which has the specific stack of dependencies and libraries that your app needs. We are able to take a cluster of host machines and be able to assign where to run our containers and distribute it as the business needs that dictate, as your workload dictates. You can be running more background processes with ease during the night and then running more front-end web processes during the day. It provides better resource utilization, and this is not to be discarded. When you're managing huge infrastructure with hundreds of servers, then having a server density maybe 2-3 times higher than with virtual machines, that is going to be a lot of cost savings that are interesting for your business. And containers are actually able to boot sometimes in less than a second, sometimes even in milliseconds. And so it makes it very easy to scale up and down the containers as you need. So now we go to our next point, and it's about, well, I want to Dockerize my apps. I want to use Docker for my applications, right? What should I do? Well, there are some architectural constraints that you should follow in order to be able to fully utilize the power of Docker containers. And so this is nothing new. We have the 12-factor app. It's this methodology for creating web apps that can scale on the cloud. And this was written by the people from Heroku quite a few years ago. And it's more valid today than ever. And I'm not going to talk about the 12 factors, but I'm just going to mention briefly the ones I think are most important when you're actually working with containers. The first one is store the configuration in the environment, right? So when you have the same code and you want to run the same code on all your different environments, then what is likely to change between your different environments is not the code, it's the configuration that it needs to be set. And so by using environment variables, we have an operating system and programming language agnostic way of being able to set different values for different environments. Another one is treat backend services as attached resources. So in a 12-factor app, your external services, so for instance, your database, are just attached to your application. So basically, your application should not have a reference directly to the database that it's going to be using. An operator should be able to, let's say in case the database has crashed, he should be able to, or she, to take the the data, the dump, the backup, put it on a new server, change the configuration that you have in the container, restart it, and should be able to have your application running. You also should be able to replace local services with external services. So you could replace MySQL running in your data center for a MySQL running in a third party hosted somewhere else, and it should be transparent for your application. No code changes for that. Execute the app as one or more stateled processes. This is a very important thing because we don't no longer know exactly where in our data center things are running, right? It's not like before that you have this VM, you connect to it with SSH, and you're sure your application is running there. Things could be running in different places. One request could be taken by one server, next request goes to a different server. So you cannot rely on having things present on your file system, for instance. You could use it as a cache. You take your request, maybe a file upload, process it, and then you would upload it to a stateful server, let's say something like S3, that is outside of your process. Same thing goes for sticky sessions, right? So you should not rely on the same server responding to subsequent requests. You should be using something perhaps like Memcache or Redis to be storing your sessions. Maximize robustness with fast startup and graceful shutdown, okay? This is also really important. We want to be able to start our containers really fast so we can actually be scaling as fast as possible. But we also want to be able to handle shutdowns, right? Remember, we're shutting down things and starting them all the time. Then we have to be able to gracefully handle a shutdown. So basically, when your application or your processes receive a sick term, then they should be able to handle that gracefully. For instance, a background worker, when it receives a sick term, then it should terminate its actions, but it should first put the job back in the queue, clean up, release any logs it may have, and then terminate. And then another one, it's treat logs as event streams. So logging is a bit of a controversial subject, and what the 12-actor app says is logs are not an application concern, they are a platform concern. So what their suggestion is your app just simply logs to a standard output, and then your platform will figure out a way to take this. Maybe you route it to syslog, and there are tools to do this, or you will use a service like Graylog or Kibana, and then send your logs there. But it should not be a concern of your app. So we have now the challenges, right? It's not everything is perfect, and if you've heard about Docker, there are still many questions around the topic. And so we have the first one, it's about service discovery and registration. Where are actually things running? Well, when our containers will start somewhere in our data center, we first need a way so that our containers announce themselves to the world. They have to be able to say, hey, I'm here, I'm able to take requests. And then the other applications, they need to be able to find where the other services are running. So they should be able to go to a service and ask, hey, where is my database? Hey, where is my Redis instance? Networking. So this is also a hot topic. How do containers talk to each other? When you have different containers running on different hosts, possibly even across different data centers, then how are they going to be communicating to each other? It's still a topic to be resolved. There are quite some tools like, for instance, Weave, that are making progress in that space, but it's not yet a solved thing. Persistent. How do we store data? Problem is, when you're writing your data to disk, then you're basically tying your container to a specific host, right? If you have a MySQL database and it's running inside a container, the moment it writes its data to disk, then that data is residing there physically. And so you're not able to start this container somewhere else and reference the other data. And so how do you move containers around when they have actually data that you need to be persisted? Also, lots of experimentation in that field, but nothing solved yet. So, for instance, right now, I would say, if you have a MySQL database, just use a virtual machine for it. And then we have the security concerns. And so how do we isolate containers from each other? There are some concerns about running untrusted code inside a container. And also, the Docker daemon has to run as root on the host. So in theory, if somebody got out of a container, it could take over the host machine. Actually, the Docker people are working, so it's no longer a requirement to run the Docker daemon as root. But the other questions still remain open. OK, so I think it's now time to show my demo. And, well, right, sorry. So before I do that, I will just explain briefly the architecture of the demo. So for this demo, I'm running actually 3 virtual machines in my computer. And they're using a technology, it's called Docker Swarm. It's a native clustering solution from Docker. And so what happens is the following. When we start a container, the Docker daemon is going to emit a series of events about its life cycle. So when a container starts, it emits an event that is start. When it stops, it will say stop. If it dies, the same. So we have a container as well. It's called registrator. And the role of this container is to actually monitor the stream. And when it detects, for instance, that a container has been started, it's going to be talking to console. And so for those who don't know, console is a strongly consistent distributed key value storage. And so this is going to be our central point where everybody is going to be writing information about where they are, and the others are going to be able to find other services. Then we have our application, and it's going to ask console about information for its Redis database, which is what we're going to use in this example. And finally, we have HA Proxy. It's our load balancer. And HA Proxy is constantly monitoring changes for console. So anytime a service is registered, it will regenerate its configuration and restart gracefully. And so it's able to balance the load between the next, all the containers. So showtime. And I hope this works. OK, starting our VMs. And so let's go for a second here. Take a look. So this is our console interface. And we can see all the services that we're running here. Actually, this looks a bit ugly. OK, looks better now. And we can see all the services that are running here. So registrator has picked up, for instance, that I'm running Docker Swarm as a container as well, and it's registered it. So now, go back to our demo. And we're going to start a Redis container. And that's all the time it took to actually have a container running. So we're talking about milliseconds. We come here again, refresh the page, and now we can see we have a Redis container here. We click on it, and we can see it's running actually on one of our 3 nodes, so the N2 node. We go here. We're actually going to look, and we say, OK, so this is our Redis container. And it got dynamically assigned the port 32768, OK? Get that number in your heads. So now we're going to start HA Proxy. We come back here, to our services. We see HA Proxy, and we see it's actually running on this host as well dynamically. So, all right, got that. OK. And now we can see our HA Proxy started, but there are no backend services to respond to this request. So let's actually start our Sinatra container. Start our Sinatra container, do the same. To double check, we have Sinatra here. It got actually distributed to the N1 node. If we go now to our HA Proxy, voila, it's running. And so we can see it here. This is the ID of our container. And as we can see, it connected to console as well and got the information about Redis from it. And so we can see our Redis host where it is and our Redis port. Now, let's start another container, and let's refresh the page. And now we can see it's actually balancing the request between the different nodes. Okay? Let's stop the container. And now we only have requests coming from handled by our first container. And that's all. Thank you. So we still have a couple of minutes for questions.
Yes? Questions?
Hello?
Yeah, there is one there.
Okay.
Then
So on your right?
yes, here. Jorge?
On your right? Jorge?
Oh,
Hello?
on the right, here.
Hi.
Oh, okay, sorry.
It's okay. So if you got an application using a certain port inside the
Can you speak a bit louder, please?
Yeah,
Sorry.
okay. Inside the container, the
Yeah.
application runs on a certain port, like a MySQL database on
Yes.
3306. What happens with the port on the host operating system? Will that be blocked?
Okay, so, well, there are two ways to run it. When you start a container, you can tell the Docker host, I want this container to be bound to a specific port. If that port is actually available, then you get the port and that's it. If not, then you can use dynamic port assignment. And so basically what you do is the Docker host is going to listen on a random port that it has available, and then it's going to be routing those requests to the port that your application is actually listening to. So as we saw before, for instance, Redis was listening on port 32768, but the container itself is listening on port 6379, which is the Redis port. Of course, if you have two containers that want to be bound to the same port, then it would fail. You will not be able.
Okay, there is one there in the left.
Hey, so I was just wondering, what did you use to update the HA proxy configuration in the demo there?
Okay, right. So I will actually publish the code. It's actually on my GitHub account, and I'm using this tool. It's called Console Template. And Console Template, what it does is it's a program. It's written in Go, and you're able to declare the services that you want to listen to. You can also listen to particular keys that are registered on console, and it's going to be actively monitoring for it. And the moment that a change happens, it will generate the new template and execute any command that you tell it. And so in our case, we have the HA proxy configuration template, and the command is to do a graceful restart of HA proxy in that case.
Oh, okay, and console template runs in the same container as HA proxy or on a separate container?
Yeah, with console template, you can basically generate any kind of configuration that you want, and it will make sure that to listen to the things that it needs to be able to run.
Okay, thanks.
Okay, we have one here.
Hey, are you using Docker?
Yeah, well, right now we're still not using it, not in production. We're still working on making our ways to using it, for instance, for running our tests. And it has some advantages because, for instance, we can have our MySQL database, in this case it's ephemeral, and we have it preloaded with the fixtures and the seed data that we need. And so you can run your integration test, you mess up with the data, and then when you're finished, the container is destroyed, so the next test run is going to be running again a fresh and clean database.
Yeah. And the next question is, if you're using, where do you store the Docker images? Do you use the distribution, I think it's called at the moment?
Yes, so
the registry?
We are using the Docker registry. So we have a server internal to our network, and it runs the Docker host, and the Docker registry itself runs as a Docker container, and then you can run the indexing service as well as a container. And yeah, basically you just install the Docker daemon on the machine, and then everything on top of that is just containers.
Okay, one last question there.
Actually, I have three, so.
Quick.
We have
Let's call
one
them
minute
quick.
and 40 seconds.
Maybe 2, and we talk about the third one.
Okay.
Let's negotiate. Okay, so first one, how do you handle failure recovery with console? Because, you know, there's the bootstrap parameter, and you need to provide it the number of nodes, and you hit the split brain. You know, it's unable to elect the master because if it's an even number, it's unable to choose who's going to rule. So if you give it an even number of nodes, it will not be able to elect the master for you. So how do you handle that?
Yes, so, well, actually, we have our bootstrap level set to 3. We are actually running 5 nodes. And, well, if we have a split brain situation, then, well, you will always get like 3 in one side and then 2 on the other, or 4 in one side or 1 on the other.
Yeah, that was my...
Okay.
So
Yeah, that's
you're
how we're
running
doing. So
that-
we run 5 nodes. You should not run more than 7 nodes because since the writes have to be consistent, then of course the more nodes you add, then the slower it gets to actually perform the writes. So we're running right now with 5 nodes, and we need a quorum of 3.
And second one, what do you feel, or how do you feel about Docker Compose? It's formerly Fig, and now Docker Compose.
Yes, so I'm actually using it to, but we're not, to be able to, for instance, run the tests. So you will write your Docker Compose file, you declare the images that you need, and then just run them. So we're actually using it, but as I said, we're not using it in production, not even on staging. It's just, right now for development and testing, we're kind of using it for that.
Yeah, that was where I'm aiming.
Okay,
two.
you can ask the one in the break, okay? After we finished, okay? Thank you, Jorge.
Okay, thank you very much.
Nice presentation.
Will you take this?